Okay, first podcast of Unit 6 is talking about molar mass, which is a really simple idea. You'll probably get this after the first example or two. And we're just going to be filling in page 2 and our packet, top to bottom, and that's it. And the most important part is these basics and remembering what a mole is, because we've actually talked about it before. Back in Unit 1, when we talked about units, mole, abbreviated MOL, is the standard international unit for the amount of a substance. So if I want to tell you how much water to use in an experiment, we're going to be using moles to describe that. Now, technically what we're talking about is molar mass, which is a little bit different, but the units for molar mass are G/mol, grams per mole. And this is technically telling us the mass of 1 mole of atoms or molecules. And we're going to be using this in this form here, turning our molar mass into some little unit equations in order to do some conversions very soon. So right now, easy problems finding molar mass, but in the future, this is going to be step 1 to get a conversion factor so that we can do more math with it. Now, that molar mass we're talking about is the number that's going to go in here and fill in this blank. So depending on which compound you have, it's going to have its own molar mass. And the way we find that is by adding up all the individual masses of each of the elements in the compound. And we're going to use a periodic table to find their masses. So not even really much to memorize. As long as you know how to do it, you're good. So the key is to use the periodic table, and all these little masses that we haven't really been using so far, this is when we finally get to use them. So all of these different elements just have their own masses. So if I asked you what's the molar mass of copper, Cu, I'd look at the periodic table and 63.546. That's its molar mass. As long as I can add some grams/mol, grams per mole at the end there, then that's done. If I have something a little more complicated like Cl2, then yeah, I'm going to have to look for chlorine on the periodic table and find its mass. But now I need to multiply that by 2 in order to get Cl2's mass. But then 70.906 is my answer. Just need to make sure to get those grams per mole on it. With something like H2O, we've got hydrogen and oxygen in there. But if we take it one element at a time, find hydrogen on the periodic table, has a mass of 1.008, multiply that by 2, because a little subscript 2 is on it, to get the mass of hydrogen in this compound, and then find oxygen, and there's just one of them. So I'm going to add the hydrogen number, the total hydrogen number here, with that oxygen number, and get my answer. And that is my molar mass of water. Just make sure to get those units on there. Now, we can get some molecules that are bigger and more complicated, but it's really just about knowing how many elements of each there are. So I find sodium and its mass. I'm going to multiply it by 2. And then I'm going to find sulfur. And there's just one of it. So I'm just going to add that up or set it up so it's ready to get added in with sodium. And then we have oxygen, and there's that mass is going to have to get multiplied by 4 before I add it up and get my final answer. So it's just about knowing your elements, how many are in each of these compounds, and being able to do some simple math. Now, quick side note, I will have to see some kind of work on the test, but the only kind of work that I have to see is these individual numbers for each element and then the total. And, I mean, of course, we'd need the units on that. So I don't technically have to see any of this stuff written out. As long as I can follow your process here, this is still math, and in science we show our work. I mean, in math class we probably do too. So makes sense. I can't just have this number magically show up here at the end. I need to have some kind of work, and at the very least it would be show me these intermediate numbers that you're about to be adding up so I can see some kind of partial credit, partial work. But moving on, Ca3PO42, this is calcium phosphate. And once again, just take it element by element. Calcium's mass times 3 gives me this. Then I have phosphorus, and initially it might look like I just have one phosphorus here, but because that phosphate is in parentheses, this 2, and I'm going to change colors real quick, this 2 distributes in to the O and the P. So initially that looks like 1P, but times 2 means that there's 2 of them. This looks like there's 4 O's, but really, with that 2 on the outside, that means that there's 8 of them. So that's phosphorus's mass times 2 gives me this. Oxygen's mass times 8 gives me that. Lots of numbers, but if I'm careful, as I add these up, it gets me my answer, and I just need to make sure to stick grams per mole on it. Now, you see, these examples get a little bit more tricky because it doesn't give you the formula, but we've got the skills to write these formulas, and covalent are easy. Sulfur is S. Dioxide means I have 2 oxygens, so SO2 is my formula. And from there, the process is the same. Find S, find O, make sure to multiply O by 2 before we add it up, and get our final answer. Make sure you get those grams per mole on there. That's going to have a lot of meaning for us later. So it just seems like extra stuff now, but it's going to help you make sense of some of these numbers and conversions later. So this next part, oxygen, you might think that this is just O, but it's not. Remember, oxygen is a diatomic, so that formula for oxygen is O2. Not a hard molar mass, but let's go ahead at the bottom of our page to make a note about these diatomics because they didn't show up on this last test. They're definitely going to show up on this Unit 6 test in a couple different places. So down here at the bottom, remember diatomics. There's a couple different ways to remember them. Brinkelhoff is a word made out of each of the symbols of each of our 7 diatomics. I bring clay for our new house. Each of those words starts with the symbol of a diatomic. Or you can use the periodic table, and if you start at element number 7, make a 7, and don't forget hydrogen over here. Those are all of our diatomics. So make at least one note to remember those and one key or one way to do so at the bottom. And let's go back to oxygen. I just have to find oxygen times 2, gets me my answer, and we're done. So I'm going to help you with this next formula, but I'm not actually going to find the molar mass. These last 3 compounds, I'm going to have you find the molar mass, but I'm going to help you with the first 2 formulas at the very least. So this is aluminum oxide. And if this doesn't have prefixes like mono, di, tri, after I find what aluminum and oxide are, I need to find their symbols, done, and charges. So aluminum had a +3 charge. Oxygen always has a -2. And then we're going to cross-drop reduce these charges so that my formula becomes Al2O3. So find Al and its mass on the periodic table, multiply it by 2, find oxygen times 3, and then add those up. Make sure you get this answer and put grams per mole on it if you want to get a stamp. These next 2, I'm going to help you with those formula for potassium phosphate, and then iron 3 sulfide, you're on your own. So potassium is K, not P. I saw so many people put P for potassium on the test. Phosphate is on the back of the periodic table, PO4 with a -3 charge. So this +1 and the -3 are going to cross-drop reduce to get us this formula. Now go through those steps to find these elements and their masses and find that molar mass. I'll show you a periodic table in just a second if you need it. And then just remember for a hint on iron 3 sulfide that this Fe is a transition metal, so you wouldn't know its charge if it didn't have this 3 in the middle. So that's trying to tell you that Fe has a +3 charge. I'll leave the rest of this to you to find sulfide and its charge, cross-drop reduce, and then of course find its molar mass. So for those of you without your own periodic table, here is a smallish version of it, but this should be able to help you finish things up. And that is our podcast.